Hi, I am, as it says up there, Paul Phillips, and I'm going to talk to you about Scala collections and about how I might write Scala collections differently. Well, did a little bit. Some of the information has already been overtaken by events, because I don't know how much longer I can write Scala without jumping off of something. So let's take a look. When I'm working on a problem, I never think about beauty. You've all seen this quote, because there's only like 10 quotes that are relevant to programming, and they just get recycled over and over. When I'm working on a problem, I never think about beauty. I only think about how to solve the problem. But when I have finished, if the solution is not beautiful, I know that it is wrong. To a first approximation, I think this is a fantastic quote, because when something there's an intuitive feel that you develop after a while of programming. You just know you're going the wrong way. Some people get that intuitive feel faster than others. This is, I think, the point at which you should know that the solution is not beautiful. This ungodly thing that you're looking at, which is a little difficult to read in the red, this is a single boilerplate trait, the baby of a boilerplate baby of another boilerplate baby of another boilerplate baby, as views in the Scala collections metastatized outward, creating more and more of these things. If you look, it's all just trying to propagate these type parameters it's completely nuts, is what it comes down to. There's just no way something like this ever should have seen the light of day. But we were, like, that's still in there. I guess it's finally been deprecated maybe, but this is essentially like what the architecture of views led to. And they still didn't work at all. But this made it impossible to work on the collections. You got to imagine, you go and you want to fix something that matters that people use. You make a little change, and then now you get this 9-page type error from some unrelated file because something didn't propagate quite right down through all this type parameter madness, and it's your problem to figure it out. Well, so you think, screw that, and you just abandon the thing you were trying to fix, the thing that matters. Whereas this thing has never been used by a living human. It's nuts. Oh yeah, so my slides, of course, are in this sort of random order because I just barely sort of got them together. It's not that I didn't work hard on them, it's just there's never enough time. I better tell you who I am because not everybody knows. I spent most of the last 5 years, like most of my waking hours, working on Scala. And I just said, I can't do it anymore. And I quit. I feel great about that. It's really nice being on the outside and not having a horse in this race. Because now I can say what I think. Maybe you think I was saying what I think all along because I have something of a reputation for being a little bit difficult, at least in the sense of saying things nobody wants to hear. And nobody did want to hear them, and so that's why I'm on the outside. But there's still an awful lot I never said. And of course, you guys are all like pro Scala, that's why you're here. So already you're thinking, oh man, the last thing I need is to be sitting here having this guy rag on Scala for an hour. Yeah, well, I'm also a really optimistic person. Something good will happen to you one way or another, whether it'll be in Scala or something else. And I feel also that I should tell you why you should care what I say. Because I have written an enormous amount of Scala code. This is my little graph. That's me, whatever that means, 1 million lines of code on the main code base, way more than anybody else will ever do, because it's much more difficult to actually get stuff into Scala now than it was when I started. So forever, I will be the leading contributor there unless somebody rigs the stats. And then furthermore, this is the bug database, where I have closed 900 tickets and opened 482. That's 482 bugs I've discovered personally, approximately, which is kind of sick. Really, I don't think anybody should be required to discover 500 bugs in a programming language. And yet, they continue to roll in, right? Just trying to put together this little thing, these slides, I discovered half a dozen. I think I'm going to hang it up at 500 and just say the bugs are somebody else's problem. So I genuinely believe I've written more Scala code than anybody else, living or dead. I'd be surprised to find otherwise, honestly. Because now this is more an indictment of me writing too much code and like not thinking enough than anything else. But regardless, it's true. And so for that reason, like I have to be allowed to criticize this thing that I've invested so much of my life into, which is what I will end up doing here today, possibly more than talking about anything else that I've done. There's not enough hours, etc. I mean, in this case, it's even more true than usual. I cleaned up lots of error messages so that you could tell what was going on in the slide. Really, they're a lot harder to understand than there's nobody sitting there like trimming off all the package names and stuff to make it look pretty for you in real life. And I'm not coming over to your house to do that, but I did it for these slides. So you have to imagine everything is like much harder to understand than you actually see in these beautiful slides. So I gave this talk a few months ago that some of you will have seen at Pacific Northwest Scala, and it was called "We're Doing It All Wrong," and I listed a number of grievances I had with Scala. And one of the things I saw in the commentary afterward was people got kind of the wrong idea about why I quit, and this is my fault because for obvious reasons, I don't want to like be sitting here slagging off, people, if I can help it. But I didn't leave over technical issues. I left over directional and communicational and basically like decision making. There are no intractable problems with Scala, but they are intractable the way they're dealt with in Scala. And so they won't be handled. And eventually I had to face that. They will never be fixed. So it was not like there was no technical challenge that I would not take on. But technical challenges where your hands are tied behind your back, that's not so fun. So that just says blah, 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 blah. If you really want to know, go Google. You can find plenty of stuff from me on Scala internals and everywhere else. Like anybody would be able to figure out what the issues are. I just want to make sure that get that out there. That like, hey, it wasn't like JVM or Java compatibility that was the problem. So this comes up every few months, I guess. Is Scala too complex? Yes. I don't know what other answer is possible. I see these weird sort of Stockholm syndrome type answers sometimes. All this complexity is necessary. No, it's not. It's complex because, I don't know, it's whatever excuse you want to give. It's ridiculous. Scala is a huge set of interacting features. The world's largest set. And there's just no amount of saying like the language grammar is small or any other sort of artificial measurement can change any of that. The fact is the number of corner cases is astronomical. Just look at the bug database. Nobody can spend 2 hours with the bug database looking at the bugs coming through and ever say anything except Scala is too complex. It's impossible. You could not do it. Anybody that says otherwise has never done that task with the bug database. For years, I would go through the bug database in its entirety, looping. I naively thought when I started, I would reduce the open bug count. In those days, there were like, 200. Now, I don't know, there's thousands. And it's not because there's more stuff. It might be because there's more users. And so more of them are uncovered. It's still just the tip of the iceberg. You could sit there like churning out, just by taking any two features and exercising them in combination, you will find bugs. And it's never going to be robust because you don't get to a robust endpoint by starting with something that leaks like a sieve and patching the holes. You have to engineer it, and there's too late for any engineering. It's a real problem, and certainly it's got to be a litmus test for complexity when you very often have no idea whether the bug you are faced with is even a bug in the language or not. There ought to be some canonical way to determine, is this my bug or the language's bug? I hear it all the time. People don't report bugs because they don't know if it's a bug. I totally understand. I don't know either. So this, as I said, that goes around from time to time. Well, there's three things we could do if people think Scala is too complex and we think that's a problem. We could own it. We could say, yeah, Scala is pretty darn complex because it has complex problems. So you don't like complex, go away. Or We could lower the complexity of the language, like say, you know, you're right, it's too complex. Here we are decomplexifying it. Or we could try to hide it. Could say, it's complex, but if they can't see it, then it's not. So option C, after much debate, was settled on, and thus was born the use case. Now, the use case is emblematic of the problem with the collections. It's this style over substance triumph that still makes me ill, as I'm sure will be apparent from my choices of words. So the use case says, well, these signatures are too complex, and these, you know, who are these people that are talking too complex? It's just because they're ignorant. You know, that crazy signature is like, if they couldn't see that, it'd be all right. So let's distill down the actual signature to a different one that's not complicated, and we'll say that's like it's the use case. So the documentation tells you that's a signature of map. Look at that. That's a map B. What is a map B? I don't know. It's fiction. It's not even well-kinded fiction, right? It's in the ill-kinded fiction section. And then here's the full signature in quotes. Also an outright lie. What? B again? It's mapping B to B? What's going on, man? They're both made up. They have no basis in reality. That's the official documentation. Let's see what map actually should have for a signature. Well, whatever you're going to try to do, if you want to be able to distinguish between map's second type parameter, which is called B, and the incoming method type parameter, which is also called B, you need to actually break them apart. So here we are going through the crazy Scala reflection to get our hands on the actual signature, which is down here. And as you can see, this is the B in the method. Here's the renamed B as a V. Point being, it's completely different than the one in the documentation, but there is no way for anybody to know that. It's not, there's no warning label, we just made this up. It says that's the official signature. So you think, okay, well, big deal. You just went and you like cherry picked a bug that just happened and it'll be fixed tomorrow. Well, see that date? That's 17 May 2010. I didn't look that hard. This was the oldest one that quickly came up. That's 3 years it's been telling that lie. Your time is worthless. That's the message that comes out of that to me. And I don't want to send that, your time is not worthless to me. I don't want to be part of something that thinks your time is worthless. Telling these lies in the idea that it'll make people think it's less complicated. It's crazy. You know, it's like you have to face reality. That's the signature. Don't give them some other signature. If I sound emotional, remember that I've invested 20,000 hours into the language, all right? And I had to quit, not because I wanted to, but because of stuff like this. So I think I'm entitled to a little bit of emotion about it. So all of this is to hide that map signature. Map, the second one, that's map. Okay, because that's the actual, that's the signature we're trying to hide. I run out of words. That thing over there on the right. Now there's the beautiful one, well known from languages like Haskell. They just call it map or fmap maybe, and it's an A to a B and then end of the story. Pure, beautiful, reusable, composable. And then the other thing, none of those things. And then what do we get out of it? We get the bit set gimmick. That's like the essential, what it delivers. I'll get to the bit set gimmick in a moment. And of course, Ryan Gosling's a handsome man. Nobody can deny that. And Gollum isn't. The bit set gimmick. So all of this pain that comes with can build from, which is quite substantial, is so that we can do things like call collections methods on some random thing that doesn't even subclass the collections and get the same thing back. So for that to happen, you have this whole little sort of rectangle of action. You've got to somehow go from your thingy, whatever it is, a bit set or say a string also. It's got to go into collection land. It's got to follow some method that acts on its elements. It's got to come back out. as the original kind of thing. And in the course of doing that, it has to get its hands on something that knows how to build it so that if the elements are transformed into something else, they can be reassembled into that thing. So here we are doing that where it's working. Great, look. We have a bit set with 3 elements, and we call this map that goes through some crazy string back to int transformation, and we get a bit set back. Wonderful. Except, this breaks down all over the place. For instance, these are not equivalent. Now look what we're looking at here. Collection, map, then 2 things. And then we have collection, map thing, map thing. The fact that these are inequivalent, that you get completely different types back out, means you cannot reason about anything. It means it is not, you can never pull an expression out, assign it to a thing, and then use the thing in its stead. You get different things that way. That makes it impossible to reason. And then here we have a different exciting problem. We call map identity, and then we try to check if 1 is in the resulting bit set. Failure, what happened? Oh, well, it thinks that this is the second argument to map, the can build from, the one that we're trying to hide. Of course, you hid it. We don't know about it. So this would come as a total surprise since we were given the use case. There's no way to know. What is this can build from it's talking about? I've never seen that in my life. They told me I'd never have to know. Well, obviously you do have to know. There's no way to avoid knowing. It's only a question of how much you're going to suffer in the course of acquiring that knowledge. Similarly, we have all these features that are not in the type system, and so you start out with them in a collection, and do they come back out when something happens to it? Who knows? There's no way to know. If it's not in the type system, there's no way to know. Sortedness. Here's a sorted set with 10 things in it. Here I am mapping it across a function. Oh, look, it's still sorted. Here I am mapping it twice and losing the sortedness. How do you know? You don't know. There's no way to know. See where on this one, it's the same thing is happening in a single operation. We're calling F, getting it back out. In this one, it does a 2-hopper. And remember, each of those maps is bringing in a can build from and building a new collection. So if the intermediate map cannot hang on to the end result, then it's gone. You never get it back. So again, we've destroyed compositionality. There's no composition left. And then it gets worse. Set. So map is considered to be this sort of universal thing. And then it's placed at the very top of the hierarchy, which includes all of the collections types, including set. So in set, it's apparently a more important invariant that there be no duplicates in set than that map follow what's sort of like the fundamental thing of map, which is that you get the same number of things out that you put in. So now we can enjoy stuff like this. Here we are calling map F, map G, and here we are calling map F and then G. This is essentially the same example as all the others. We're either calling a function and then another function, or we're calling the composition of those 2 functions. But in this case, it's not just a different type. It's a completely different result. Why? Well, because set, if they're duplicates, eliminates the duplicates. So set says, if we're doing mod 3, and we put 369 into it, they're gone. So there's only one answer comes out of that. Then we map that one answer, and we get one thing. And in the bottom, since they happen at the same time, that intermediate set builder never comes in to squish 3 down to 1, and we get 3 answers out. Now that one's obviously somewhat contrived, right? You don't write a lot of functions and just pick out system.nanotime based on sets. But I assure you that the consequences of this are not contrived. I can give you a good one. Sets hash code. So the way that sets hash code is generally calculated is to take all the elements in the set and sum the hash codes. Okay? So the natural way to do that is to take the set, map to hash code, and sum it. Works, except it doesn't sometimes. Why doesn't it work sometimes? If any 2 things have the same hash code, oh, they're gone! You only get 1. This kind of bug is almost impossible to see. You've got to constantly, and it may not be obvious that it's a set. Remember that map is defined on traversable. So let's say you write a method that takes iterable coming in, and you call map on that, what's going to happen? Who knows? There's no way to know. They can call it with a set. They can call it with, whatever they want. Maybe stuff disappears. Maybe it doesn't. Who knows? It's a mystery. Java interop. I call it the cruelest joke because it would be one thing to suffer for Java interop to achieve it. But to suffer for Java interop to achieve nothing is more like what we do, and that is a crime. So there's a ticket, and I really, I encourage you to enjoy all the details there. I opened that years ago because I could not figure out how to call map from Java. I just wanted to literally just somehow find the incantation in Java that would allow you to call the method at all. It's impossible. As far as we know, I guess you can take this as a challenge, but Martin couldn't do it and I couldn't do it. So that's not promising. I'm just going to read the quote here. I played with it until it got too tedious. I think the signatures work fine. What does not work is that the variances of can build from. Notice how frequently can build from has been the villain in this tale. This is what happens when you start corrupting the pure fundamental things, like map. The variances of can build from cannot be modeled in Java, so the types don't match. Java won't even let me override with a cast. So short answer, you can't call these things from Java because instead of declaration site variants, you have only a broken wildcard system. This is a very common theme in Scala, blame Java. And indeed, won't fix is the resolution of that. That's a closed ticket, not an open one. You just can't call the collections methods, not that one anyway, not any one that has an interesting type signature like map. So I have such a large but disorganized list of grievances along these lines that as my time ran out, I said, all right, well, let me just see if I can funnel them into a few slides, because I would like to spend at least a little time talking about something other than what's wrong with the collections. So let's see. Implementation details are everywhere, and there's no separation of the interface. There's no point at which it says, like, here, we've thought about this in sort of an abstract way, and here are the fundamental bits that define this collection and how it's going to behave. And then over here, we have an implementation of that. There's nothing like that. It's just a morass of interface and implementation everywhere. And there are just no clean boundaries, and there's not even really an attempt at it. So the only way to really know, like to attempt to interoperate with it, is to study the implementation. To your dissatisfaction, surely, if you ever actually do that. Variance is poorly managed at best. A perfect example is contains. So because contains is defined on seq when it's covariant, everybody inherits that. And if given that it's a covariant type parameter, the upshot is that contains takes any. So all of our, if you have a list of ints and you call contains a string, there's no warning, no type error, nothing, it just says false. Doesn't give you the tiniest bit of help. It's just your problem. This is not exactly a far-fetched sort of thing. This is everywhere. Having like a list of things and wanting to know if it contains another thing, like what is a type system for if it cannot tell me that I'm asking about some completely unrelated type that will never be true? And yet, gone. And the reason is that contains is defined in the wrong place. It must be defined where it's invariant. Contravariance, because of a slavish devotion to a particular idea of how specificity should work in the face of variance, contravariance is rendered useless. Consider, take a class like ordering. Ordering defines a single method, compare. So it compares an A and another A and tells you how they relate. Now, if I had in my hands two possible orderings, one of which compares an any and another any, and one of which compares some super specific type only, right? It compares like chairs that are missing a leg, and it can take two chairs that are missing a leg and compare them. The other one compares any two things anywhere. Which of these is more specific for a useful definition of specific? I propose there is only one answer to that question that makes any sense. However, Scala reverses that and says that the any ordering is the most specific. And despite a years-long campaign on my part, bringing to bear every imaginable detail of why it should not be like that, nothing happens. It's truly frustrating. So You can't use contravariance in any useful way because it always picks the wrong thing. Here you are subtyping along, making things more specific. It's determined to take the first thing, the earliest thing that it can because it thinks that's the most specific. And yeah, so, and then this is you're gonna feel this one more and more over time. Already you can see the ossification has begun in a big way because implicit selection depends on type inference and vice versa. And as they intermingle with no specification except the implementation itself, the only way anybody knows what happens in type inference is what the implementation does. Every new bit of code that rolls out becomes dependent on exactly what happens to happen right now, which nobody knows. And it's affected in completely unknown ways every time it's touched. The result is you can't touch it. So whatever type inference happens to do right now, that's pretty close to what you're going to have for the rest of your life. It's too hard to change. It breaks everything, and in like really subtle, annoying ways. So this particular intermingling is going to pay dividends indefinitely. I bet you guys had no idea what was in store for you when you came to this, huh? I can see basically these shocked faces like, don't take me seriously, I don't know what I'm talking about. So the pollution, the insensible methods that everything must implement, this is terrible. Size is a perfect example. Size is defined at the very top. So everything has a size, and everything has a size that's an int. You don't have any choice about that. That just, one way or another, there's going to be a size, and it's going to be an int. Doesn't matter if you're a stream and you're infinite. Doesn't matter if size is really, really expensive to calculate. Doesn't matter. You have that, and it's going to be there. And people can call it. And you can block them from knowing anything. You can tell them a lie, but you can't not have size. This is the wrong way to do it, right? Types are useful because we can construct types so that a thing only has the things that it has. So that when you try to do a thing it doesn't have, it's a compile time error, not something you find out later when non-termination is your joy. Then we have the very frequent bundling of what are unrelated concerns. Maybe you think that invariants and sets are inherently bundled. Well, you would be wrong. I have another slide coming up that explains what really happened there. But there's no reason whatsoever why this idea of a set has to come with invariants. They're bundled at the core of the core, and there's no way out in Scala. Nothing is final or private, basically. So all these things have entered into the public API that have no business being there. And because everything's inheritable, it's impossible to make you can't change anything, right? Anything that has made it out into the public API and in a non-final class is now out there doing stuff. You want to override it or change it around, forget it. If you have multiple methods where correctness depends on how they interact, forget it. Correctness is impossible to maintain in those conditions. Yeah, you cannot have selective overriding of methods and keep things working. It's doomed. So we had to invent deprecated non-final as an annotation, and then slap that on a bunch of methods and classes so that 2 years from now or whatever can finally do something about those. It's a long cycle. Semantics discovered instead of designed. It is truly an experimental science in there. The compiler is definitely an experimental science. It's like you strap on your moon suit and you go in there and you start poking at things and hoping the monsters that come out of the moon rock aren't too deadly. But there's definitely there's no other way to know the behavior. I mean, the specification is laughable. Specification is truly the crux of why I quit. Because it's trumpeted as this language with a spec, but the spec is abandoned. Spec has not been touched. Spec is 200,000 lines of code at least out of date, has no bearing on reality. It's just a bunch of words. I don't want a bunch of words. I want something that describes how the language actually works. Then there are these infinite variety of not exactly corner cases, but just things that you might not think about, like what is it that one should assume about how a method behaves? You have to get in front of these things. You've got to either disclaim what's going to happen, make it undefined so that you can legitimately change it later, or pick something and make it do that. But if you just never think about it and then never attempt to say anything about it, you get wedged into whatever it happens to do. And that's where we are. Here's a perfect example. Filter. If I call filter on an immutable collection and it's always true, can I give them back the collection they gave me? Who knows? Well, I'll tell you what, whatever you do, you're going to break something because we have reference equality. So you're going to have places where people make a decision based on whether this thing eke this thing. And now if you change that and you start, well, let's not build a billion element collection for no reason if nothing changed. Uh-oh, you just broke something way down the line, which had, because they've had years to assume that you will get a new collection back. So now you can't optimize. It's optimization poison not to define these things. And there's no saving the collections on this point. Map with default. When do the defaults make it through an operation, a filter, a map, something else? Sortedness, views, streams, laziness, all this stuff. You just don't know. There's no way to know. Even if you read the docs, you wouldn't know because the docs are very likely wrong. You have to find it out experimentally. Here we have a map with a default. Works on the simple case, great. Mmap identity, okay, well here's can build from again. They told me I wouldn't have to know about can build from, it's not in the use case. Well, there it is, because you can't ever use map and get anywhere near it with an apply or you're gonna run into can build from. And then here's the actual thing. Oh look, even after we manage the apply, suddenly it doesn't do the same thing it did a second ago. So here's another thing that is no longer true. Thingy map identity, no relationship to thingy. See? Because thingy, when I put 1,000 in it, I got 10, but thingy map identity, when I put 1,000 in it, I get an exception. Again, you cannot reason about anything under these conditions. Types are for suckers. That's sort of the prevailing ethos inside the compiler. 556 ought to come with a picture. Oh, there it is. That was my picture when I had the Buckminster Fuller quote, I was trying to come up with things that represent ugly, because ugly and beautiful is really what I'm after here, right? So the only thing I can think of really that was inoffensive as ugly is Quasimodo. That's which is reasonably inoffensive, I think. Anyway, but 556 is the number of explicit casts in the library. Those are just the ones that are drawing attention to themselves by being an as instance of. So what kind of typed language needs 556 casts? And again, that's just the explicit ones. You can pattern match your way to a blind cast, easy. Then you don't get this, right? So there's probably another 1,000 of those. But just that many times somebody was willing to type as instance of, because that's the prevailing ethic in there. It's like, why bother with types when we can cast? Well, that's nuts. We have plenty of languages like that. It's an amazing type system. We should use it. And naturally, when you have 556 casts, sometimes it's not going to work. And there's views. It was this kind of thing, and the fact that I tried for years to get rid of these views and couldn't, that led me to say, well, I'll just write views because this is I can't do any worse. Right? I don't need 556 casts. I don't need these random breakdowns. The reason this happens is you have that I've been talking about, views, they have to implement the same methods and everything else, like map, which means they need to take a builder, even though they don't want to build anything. They explicitly don't want to build anything. That's their point. So they need to fake the builder and then do all this chicanery. And here it is going wrong. Some kind of view is doing something, who knows? But the craziness is that the opportunity is there at all. They don't want a builder. That tells you the design is wrong. If you need a thing in your hierarchy that doesn't want to build things on a call to map, then don't build builders into map. This is a nice example of what happens when nothing's final. So in map, you've got basically two ways to get an element out. You can call apply, which assumes it's there and just gives it back, or you can call get, which doesn't assume it's there and gives you an option back, either holding the element or a none. But it's really easy for these things to fall into disagreement. And on top of that, you've got stuff like contains. What does it mean to ask if the map contains a thing? And what if get and apply give different answers to whether there's something there? So what's happening here? We ask if it contains 55. No, of course not. We try to get 55. There's nothing there, but then we apply 55. Oh, look, there is something there, right? Because it's got a default. So now this is just like painting yourself into a corner and then just being stuck dumping the paint over your head. There's no obvious right thing to do anymore, but the problem is getting to this point at all. Something's got to be the canonical thing that defines whether something is true. That thing has to be protected from inheritance. Inheritance is deadly. It's not protected, nothing is canonical, and you have no way of knowing for any given map whether get should be trusted or apply should be trusted. What contains means, who knows? We work so hard for variance. Variance isn't that great. Variance is why contains is untyped. Variance is why you can take a list of one things and a list of another things and put them together, and you always get a list back. It's no problem. Hey, here's a list. Even if it makes no sense, has no bearing on anything, it's an obvious error. It doesn't matter because list is covariant. It will happily just infer a type that works, whatever it takes, even any. Finally, we see something that isn't Scala. This is me and an invariant list. Hey, look, it's an error. Type errors are how you know your language is doing something useful. If you don't like type errors, there are a bunch of languages that will never give them to you. There's some of them. You got to understand it's the intersection of type inference and variance that is so deadly. If something is variant, that means that in addition to whatever its ostensible type parameter is, it's happy to let that dial all the way toward any or nothing, depending on what the variance is. If you combine that with inference, which says, well, I'll just keep moving it until I get what I want, this is a terrible combination. It means that thing is untyped. It'll just come up with whatever it's got to until it works. That's bad. That's not good. Oops. Sorry, I must have leaned on that. Okay. So the truly grave misstep in the collections in terms of correctness is trying to abstract over mutable and immutable collections. I will freely admit that this is what, like many of the things in here, like from the minute I ever knew about them, I said, please don't do this. This one, I did not know that I should throw myself in front of this train. In hindsight, though, it's quite obvious that sharing a lot of code between mutable and immutable collections is nuts. All you got to do is look at the implementation to see how nuts it is. Because what happens is this. As soon as there's a concrete implementation, half the time you're willing to use it, maybe. Probably not, though, because it doesn't have the right performance characteristics. The other half, you're going to be wrong if you inherit it. So you must override so that you don't get it. You should not have things threatening you from above like drones flying overhead, trying to deal death upon their subclasses. If it's going to be a grave threat to the correctness of things that inherit it, then it's in the wrong place. And that is the case all over the collections. You cannot write drop, for instance, that it's not going to be wrong half the time. You cannot do it. It must not share in immutable collections, obviously, right? If I have like a list buffer with a bunch of, that I can just modify, I can't drop some and then give part of my mutable list buffer to some other guy and say, here's a new list buffer. And then they're sharing the same thing. That's nuts. Can't do that. But we must share in immutable collections. This is the only way we get all that performance back, is structural sharing. We've got to do it. So there's no way to get it right. It's guaranteed wrong. There are many examples of this. How much do you guys like having a collection.map, a collection.mutable.map, and a collection.immutable.map, right? We devise these conventions to try to protect ourselves from this. There's no, but who knows what people are really going to do? Anytime you see one of those identifiers, who knows? You got to be worried, and especially when you discover that the one in the default namespace is immutable map, immutable set, and collection.seek. So there's not even any kind of symmetry. This is the current situation, 24 concrete implementations of slice. That's after I did this massive de-implementationization a couple years ago of slice, when they were about the same number. So I guess they just, duplicated their way all the way back up. But really, slice, you're taking like a few elements from the middle of a thing. Are there 24 ways to write it? I mean, how is it even possible? How is it even possible, right? At the time that I cleaned this up last time, I found a bunch of bugs, like different bugs in different places. Everybody gets to invent their own little bugs because it's actually surprisingly tricky to get sliced right. That's why you don't want to write it 24 times in 24 places with 24 different people. But that is essentially what's done, and to some extent out of necessity, again, because you can't write like sanely share. I mean, this is especially sick because remember, the triumph of the collections is supposed to be code sharing. That's the message. Look what we did in 2.8 collections. We managed to share code between all these different things. You have 24 implementations of sliced. You're not sharing. So every collection's got a size. Every sequence has to have an apply. So if you've got like a 1,000,000 element list, there's nothing in the type system that protects you from somebody going like, let's see what the 1,000,000th element is. Even though that's a constant time operation if it's a vector, and that's an infinite time operation, or whatever it's going to take on a list, it's O(n), right? There's nothing that tells you. And if you program to the interface like you're supposed to, then you really don't know. It's just, whatever happens, happens. All the views have to take builders. Every set's got to be invariant. And everything gets universal equality. So I won't make any time for the devastation wrought by the methods on any. Those 3 methods cause more pain in the aggregate than I can even begin to count. Hash code, equals, and toString. None of them belong on any. There shouldn't be any methods on any. But that is going to have to be for another day. Now, the smart thing to do would have been to call stream like a failed experiment, throw it out, and say, we don't support infinite collections. But Scala continues to sort of attempt to pursue this idea that, like, sure, we can also unify infinity with this other stuff. Let's abstract over that too. Well, that's a grotesque failure. Stream has been an endless and infinite, you might say, supply of bugs. And the implementation is grotesque. It's just, you have to engineer for this sort of thing. You cannot just tack it on. So do you know which of these is going to terminate? Like, does anybody know? Can you look at this and tell me one of these terminates and one doesn't? I guess it's a rhetorical question. Maybe there is some way to know, but I don't know what it is. Anyway, the first one terminates. Second one never comes back. Set. So I know that nobody likes theory. There's 2 sensible ways to define a set. Here I've made a nice chart for you, suitable for framing. Intentional and extensional. We can either define it in terms of its qualities, or we can define it in terms of its members. Both of these make sense in different circumstances. They have opposite variance, which is critical. Opposite variance. The defining signature of an intentional set is essentially predicate. Defining signature of an extensional set is something that enumerates the members. The size of an intentional set is impossible to know. Who knows? It could have no size whatsoever. It could be infinite. I could have a set that just says like big ints that are divisible by 3. Well, that's definitely got an infinite size. You're not going to be able to figure that out by throwing things at it. Whereas this is it's enumerating, although you could allow for infinity there too. Point being, it's at least possible to know. In the Scala implementation, it's actually known. And then we have the question of duplicates, because that's the other thing that sets in Scala do, is they don't have duplicates. Well, what does a duplicate mean in an intentional set? I don't know, but it's not a meaningful question. And then the other thing is, what does it mean to be a duplicate? Well, this is where we get back to universal equality. You don't have a choice. It means whatever the equals method does. So if that doesn't do what you want, God help you. And it's sad because like the whole history of mathematics is finding new ways of deciding what it means to be equivalent. And then here we are saying there's only one way. It's on the object. That's what it is. Everything's written around that. That's crazy. We know there's a bunch of different ways, and there's no one way. Equals is a contextual thing. It is not something that belongs on an object for all time. And now we see what happened. We took these 2 kinds of sets, intentional, extensional. Here we are burying them into each other so that set is invariant. And now you see why set has to be invariant, because it's both a contravariant thing and a covariant thing in once. And then on top of that, we have these two methods. Who knows why? Why does set, why would we put this into the interface? That's what happens if you try to, say like, I'm just going to new a set and give it no methods. You discover that minus and plus are considered so fundamental that everybody's got to implement them when they make a set. Of course, for seek, you don't have to do that. Who knows, right? Like, why? I don't know. I'm sure there's some explanation. A set should be definable with a single method, either this one, essentially, or this one, and that's it. Everything else is just cruft. It's just some guys, whatever like today's idea is for implementation complexity, leaking. To do, also add all other methods. This infamous comment, checked in 4 years and 8 months ago, is part of synchronized map. So synchronized map, among many other decorator traits, is essentially a bunch of wrappers around a subset of collections methods, where if you take your map and you mix in synchronized map, then all those methods get synchronized. Of course, this design was a disaster from the get-go. If you add a method to map, nothing makes it appear on synchronized map. Somebody's got to do that. Well, I mean, how often do you think that kind of thing happens when we have stuff like to-do, add all other methods that sat there for 5 years? Never, basically. So all of that stuff, the forwarders, the proxies, the synchronized thingies, all these mix-in traits, always were broken top to bottom. Views are in this category as well. Just broken, unusably broken. There were people who knew they were broken. There were people who hadn't yet discovered they were broken and were blithely using them heading for the wall. Those are the only two kinds. There's no third thing. So in large part, these things went completely unused, but exacted a daily toll on persons such as myself. We're talking like 50, 60, 70 files that look like parseek view-like, that thing I showed you up front, with all these crazy things going on, not to mention just knowing about all this correctness just really drags you down. All this stuff it's incorrect. We know it's wrong. We know it doesn't work, and we refuse to do anything about it. Well, I can't live like that. It is, even like experienced programmers, I see them do it over and over. It's just a natural thing to do. Go, hey, let's see if the size is 0. You really can't do that. It's death. List in particular is, you walk the entire list to get the size. That this trap exists at all is nuts. It doesn't have to be like that. If you have a linear thing where you have ON operations, don't put them on that thing. Put them somewhere else, and if you're going to convert it. Anything that protects you in the type system. When you blend everything together, you have no protection. So we have all the bad side of a size method, and yet we manage to never effectively exploit size information, which is critical to doing views well in particular. You've got to be able to call size without thinking that that non-termination is possible, or that it's a million-step operation instead of a one-step operation. It's impossible to know. You can sort of approximate it by pattern matching on your collection and seeing if it's an index seek, and there's actually nothing that really links these things. This is just like a heuristic. All right, so I guess I'm done ragging on Scala collections for a little while, if that's all right. I finished my water and I could really use a water. Thank you. Anybody tell me how much time I have? An hour total or an hour from now? Really? How long do you expect me to talk? Well, I can extemporaneously speak about Scala issues. It's no problem. So PSP collections. PSP are, well, my joke is that it stands for Plausible Scala Platform, but actually those are my initials. So I really do think, though, that it could be any day. I'm just going to cut the cord. You're never going to hear from me again. Because it's too frustrating. It's just too frustrating, as you can see as I stand here talking about these things. To have lived with them for so long and now to have taken myself out of the position where I could ostensibly do something about them, but I couldn't. But now I really can't. So I think I would rather just reboot cold in another language and deal with whatever its thing is. But I don't know that for sure. I'm still sort of waffling on this point. So this is sort of an artist's conception, although it's actual code, of the kind of, like, this is more to just show you the kinds of things that are never done in the Scala distribution. This is an abstract design of things. It isn't even doing anything. It's just giving some names to things. It's making some very loose representations of what they are, and it's abstracting over assumptions. Everything is just assumed, hard-coded, and implementation defined, bang, from the get-go. It doesn't have to be like that. You can define everything in terms of abstractions with names. Nothing, you're not hurt at all. You just do that, and then you go over here and you implement this. And now this is your honesty checker. When you aren't doing what this thing says you're doing, it doesn't work anymore. Whereas, as things stand, if you're not doing what it used to be doing, it doesn't matter because you're the implementer. You define things. You change, hey, it changes with you. It's no problem. Nobody's good enough to write code that way. You must have something else. You can only have, you're a thing, and there's another thing that says what you are, and you need to go back and forth with that thing. There can't just be one thing. I love Go, the language, not because I love the language at all, but because they did something I never heard of anybody else doing. 2 implementations. That's the greatest thing I ever heard, like to have 2 official implementations, doing the spec. No one thing gets to define the spec by being the reference implementation. That is great. That is a huge step forward. It makes me laugh. I actually have to hold my laughter in to imagine somebody implementing another Scala. It would be so, the only way you could do it is to use Scala itself as your engine, right? And then you can put some window dressing on. But in the end, the only way to do, like, if we consider the maze the collections have become, we have these major divisions: mutable and immutable, seek, set, map, parallel and sequential. That's when I really should have known it was time to quit, when parallel collections were inflicted upon us. And not just inflicted upon us, but in the inheritance chain, right? Not via implicit to parallel. I begged them. Didn't matter. And views versus regular collections. That's 24. 2 times 3 times 2 times 2. So that's, basically 24 combinations of everything. 23 will have bugs. So I look at that and say, well, a set is a sequence without duplicates. A map is a set with a buddy function that maps the keys to values. A mutable collection is useless to me, and I don't want to try to write it at the same time as immutable anyway. Write your own mutable collections. I know we're never going to get parallel collections, right? If we can't get sequential collections, right? You can't get the simple things. You cannot go running when you can't even crawl, so forget that too. And views should be just how it works. And if you're writing immutable collections, that would be fine with you. If you don't have this, if you're not doing it wrong with lots of side effecting madness, you'd be glad, hey, views, good for me. That's just less work. So that takes us from 24 combinations down to 1. And I tell you, out of that 1, I get 98% of what I would get out of the collections. I'm more than happy to, I don't need a mutable collection with all the same freaking methods as the immutable collection. You know what I need out of a mutable collection? Add. It's the only thing I'm ever going to do with it is build a thing and then get the thing. It's not just going to be this long running, look at me and all my methods. That's crazy. You must reduce the surface area of things that have state. The last thing you want is for them to be doing all the same things the immutable collections are. You want them to be doing the minimum possible. Predictability. The O1 size method, the constant time size method, the linear size method, and the never size method. They're all offered in the same interface. There's literally no way whatsoever to distinguish them. I say, we're asking the wrong question. If you ask a question that cannot be answered truthfully, then you will be lied to. That's axiom. Don't ask questions that can't be answered truthfully. Ask a question that can. Like, what do you know about your size? That still allows you to give the same information as the size int method does. But it also allows you to say other things, like, I don't know, like, I'm infinite, like, I'm somewhere between x and y. And I implemented all of this in the views business for the purpose, again, of reducing the number of operations as low as possible. I want to be able to throw a bunch of things, filter, map, drop, take, blah, 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 at a thing, and then at the very end, do the minimum number of operations. In order to do that, I need to know exactly what I know about how big it is. When I call map, I get the same number of things out that I put in. That's an invariant, right? I'm not playing the little set game where they're all just going to vanish. When I call take, if I take 10, then what comes out of that is the minimum, the smaller of 10, and whatever the size info was before. In other words, these things propagate, right? So I need these operations. When I call unfold with something, it's coming out infinite. But then if I call, drop or take or whatever, I get a more precise answer. Here's an example. There's from big int 1 to the largest possible big int. If I call size on it, it's a type error. There's no size method on my for each, which has essentially a single method. There is size info, and it comes back infinite. That's a constant time operation. Size info is always a constant time operation. There's no gamble. You don't have to wonder if it terminates. As mentioned before, I have an invariant list. When I call contains with a string on a list of ints, it's a type error. This is what type systems are for. In fact, I would say that your language is a failure if you cannot issue an error on this expression. Look at it. It's 2014. That is a list of, look at the things you lose sight of how crazy it is, the things we put up with. That's an int, an int, and an int. That's a string. It's not in there. Now, the punchline of all this, all that can build from, all this map business, all this corruption that spun out, is totally unnecessary. I implemented quite easily, look what mine does. Hey, I got a string back even though it was broken into 2 operations. Whoa, man, I beat their map, right? Mine, you get back the string no matter what goes on because I'm not trying to build it at every intermediate point. I don't care until you want to get it back out. And then when you want to get it back out, if they're characters again, I'll give you a string. It's no problem. Mission accomplished. Map has a signature of A to B. It's done. If you don't like force, this can be implicit. I question the wisdom of that, but if that's the deal breaker for you, I made you an implicit you can import. All of it was unnecessary. Scala suffers from an almost total absence of meaningful criticism, by which I mean criticism that might actually take root. The decisions that are made at the top, that's the decision. You get what you get. It's not optimal, and it no longer has my input. But we can do better, much better. I believe this is actually my last slide. So if you guys really want another hour out of me, which you can totally have, you're going to have to ask questions. But as you can probably surmise, you just give me something to rant about, and I'll give it a try. But that's the end of my prepared stuff. I do have a bunch of code, though. The reason the slides are kind of lacking is actually because I was working on the code. And the code isn't that great to look at yet, but it does have, these aren't made up things. You can type SBT test and it'll do a thing and it looks kind of cool. Anyway. What's the plan? I don't know. I honestly don't know. I don't know. I don't know if I'm going to try and just cold reboot in something else. One way or another, I want to get to the kind of language that I think is possible, which is vast improvement over Scala. I don't know what the route to that is yet. So right now I'm reading a lot of theory. I'm reading about formal methods. I'm reading about alternate calculuses upon which to base things. I'm reading about Brett Victor's stuff, different kinds of, just all these good ideas about ways that we could we live in this sick textual world where we're, barely a step above cavemen pushing characters around. It's crazy. There's got to be a great leap forward available. I know that there is. So I'm just going to look for it. I don't know where it is. I don't know. Scala is, like a lot of things, was so much better than the alternative. He asked if Scala started out okay. Scala was and perhaps remains, it's a lot less clear now with Java 8, a lot less clear. But if you're way better than the alternatives, then you can be just rife with weaknesses, and you're still better than the alternatives. You know, we live in an imperfect world. To me, though, and it doesn't that's true, and it doesn't matter. Like, I only care about what's possible. That's what's interesting to me. That's why I look perpetually dissatisfied, because what's possible is so much better than what we do. And we do nothing but make excuses for how terrible software is. It makes me sick. It's like the formal methods book had this sentence. I was like, it's so true. I can't believe it. Testing. No mature engineering discipline relies on testing the way that we do. You would be considered nuts. You do not design a car and then say, well, we'll just run a few off the cliff, and then if it looks good, we'll ship it. No, you design it. You engineer it. You eliminate the problems by construction to the extent possible. It's not even on people's radar to constructively build correct software. It never even enters their minds as a possibility. Well, we're never going to make anything any good if we do not start taking the engineering part seriously. Yes. Whoa, sorry, that's a lot of hands. That was the one I saw first.
So a similar question is, what fraction of the problem is the collections library, and what fraction is Scala, and would a new collections library actually make it usable?
Well, I mean, you could make a huge improvement with a new collections library, but as much as I was ragging on the collections here, I can do the same thing with the language, the compiler, I mean, all day long. Right? And it's like maybe I'm just some guy with an axe to grind, I don't know. Any given thing that you address, it'll get a bunch better. And as is obvious by the number of people in here, it's entirely usable to achieve things with. But as a foundation of anything, and especially if you haven't encountered the real complexity, the nightmarish complexity of walking the tightrope between bugs, because I've tried to write stuff in 1,000 different ways, and I know when you're trying to accomplish anything interesting, you are by far the leading constraint on what you choose and what you do are the bugs in the implementation that you need to evade. It's a sick way to program that I have to keep in my head all the various ways that abstract types break down relative to type parameters, and what the impact's going to be if I switch to a value class, where specialization is going to break, where boxing is going to suddenly break out and make everything 10 times slower. On and on and on and on and on and on. I have to keep all this stuff in my head. I don't know how anybody else does it. And then try to design in such a way. And I'm constantly having to do these defensive things I expect to hit a bug when these things interact badly. So I need to have an escape route where I can do this. What? Come on. Can't we just make stuff that works? So yeah, Scala is not rescuable in that way. Scala is going to be an approximation of what it is right now. That's the best it's ever going to be.
So I was going to add, if people have questions,
try
and make your way over to the mic here.
That would be cool. Then I wouldn't have to pick whose hand is up, because I'm not that good at that, and I'll be unfair. But if there were people at the mic, I would just listen to the mic person.
Yeah, and it'll get picked up on the recording.
Right.
So can Scala Z or Scala Z save the Scala world?
No. It's the worst of both worlds for those guys. They get all of this pain, and when you try to, and then you have got to go up against it, because stuff like the contravariance rules, that's in the compiler. You're not offered any alternative there. You're gonna eat it and like it, and they can't do anything about that. So they've essentially had to abandon contravariance for that reason. It's a perfect example. No, they can't outrun this sort of thing. There's it dictates both the compiler but also the library itself dictates an enormous amount. 4 comprehensions, for instance, are keyed on the name. So the names map, filter, with filter for each. These are flat map. These 5 are privileged, and Scala uses them all. So it's not like you're on equal footing. There's a bunch of stuff that's just they got in there first, and whatever bad decisions they've made in predef for the default scope, any to string add, on and on, all this stuff, you can't just say well, those things don't exist. They do exist, and you have to work around them. You're already, a bunch of your budget's been blown. Please.
Are you publishing the code for PSP collection?
Yeah, I did already. It's on GitHub under PSP view, and it's, you might want to take a little while because it's these slides kind of rushed. But I mean, it's definitely yours for the using. I had a slide, I guess I dumped it, that said, because I might just be bailing from Scala any day now, I don't know if this is going to go anywhere. But I just give away all my code. It's all Apache licensed. All I want is to see better software, honestly. I swear to God, that's like all I want. And so please, you're more than welcome to anything I have.
Well, if you use another language, what could it be? Does Clojure do any better? For example.
People ask me that, and I wish I could say, if I had an enthusiastic answer, I'd already be there. I mean, Clojure is interesting to me, especially when somebody pointed out that if I was going to write my own language, I could bootstrap from a Lisp. And that's true, and that's really interesting, because bootstrapping is like a major impediment. But if with a Lisp, I could bootstrap on a very small core. So if I could take something, Clojure maybe, but Clojure might even be too big. Maybe just like the most basic of the basic, and I can just start iteratively developing in the homoiconic language, like the core that I want, which becomes my logic core upon which I can build the typed language, and I can do it all without counting on anybody else's language, which is really what I need at this point. So yeah, I don't know. I've been given so many good language. I mean, there's so many great ideas out there about how to make a language, tons. But implementations, yeah, and the ones that exist, they might be great. It's like there'll just be these tiny, like essentially abandoned bits of software. The great tragedy of these things is like it doesn't matter how good it is. If I go there and it's going to take me like an hour to figure out how to build it, and I got to upgrade Clang and find some header somewhere. I mean, it's always this endless parade of stupid things. I don't even get to see the language. So I mean, maybe there's great stuff out there, but not of the form that I want. God, it'd be so nice if it would just push button.
This is actually a very similar question, but say in the realm of safety critical software, say you were going to make a recommendation to the FAA for what kind of languages they should use in the future. It'd have to be an established language. Would you have a recommendation for that sort of thing?
You could only beat stuff with your methods, not with your language, right? I mean, I could disrecommend some things. I mean, and I would definitely disrecommend anything super complicated, right? Exclude Scala. Like, you need the simplest thing possible. But if you're going to, if you're trying to write, avionics or medical equipment, whatever, it's much more about like the actual process by which you make software than it is about the language. Now, that's also gravely missing in our profession. But yeah, it's like I don't think the choice of language is so much what matters as it is the process that's followed in the course of making things.
Right, but they used to try to mandate Ada, and
they successfully mandated Ada.
Yeah, well, they dropped that a long time ago. And,
well, right,
but
for a time.
Not many programmers seem to be interested in Ada.
No, not many seem to be interested in formal methods either.
It seems to be dying. And
yeah, absolutely.
So the choices.
JavaScript's where the action's at. I mean, I can see the handwriting on the wall. It
seems like the choices are, there's not many choices. Like there's Java, C++, C, Ada. They're not going to go out and pick some.
These things are absolutely true. It's a sign of the savagery in which we live, right? I mean, like the uncivilized nature of our lives. That we have like no good thing that we can say like that's a robust foundation. I mean, Haskell has got to be the closest thing in this, and I don't know like how viable that is, but at least in Haskell, right? I mean, like there's more so than anywhere else that I'm aware of. Like there's lip service given to the things that matter. My last talk, I have a slide that says performance is tail, something else is tail, correctness is dog. Correctness is dog is like basically, it's just not how it's done most places. It would be nice to see more of that. So yeah, I mean, if what that amounts to is like, well, we're going to use something like Scala because it's like, there's not like there's any great alternative for X, Y, or Z. Very likely true.
It seems like the best alternative is probably really Ada, but the problem is,
well,
nobody wants to use it. I don't.
Programming is largely cultural and like tooling and all these other things too, right? I mean, it's much more than the language, and so that's a double-edged sword. I assume that the culture around Ada, I don't know what it is, but it's probably like not going to be attractive to a lot of people. That's not a slight on Ada people. It's just like not what they're looking for. I don't know, but yeah, I think secondary aspects have a lot more to do with how a language is to use than the sort of language itself.
Thanks. How about creating your own language?
Well, I mean, I want to do that, and I don't want to just throw my life away. It's like sitting in some ivory tower, built up out of beautiful ivory, making my ideal language. I do want to I'm happy to do that. I would love to do that. I need more than my own two hands. I mean, I'm fast, I'm good, but I can only do what one person can do. That is my great limitation. And what I am not good at is either managing people, organizing people, persuading people, like bugging people to get, I'm just not good at any of that, right? I can totally work with people if they want the same thing I want and we're pointing in the same direction, and that's the best I can do. If anybody wants to work with me on, if any of this if I don't just sound like some crazy jerk, I would be thrilled to have some other people pointing in the same direction as me. But yeah, I don't know if that's viable by myself.
It's interesting. So this on PSP collections is you're dealing with primitives that are unboxed in any of your collections?
Well, so here's what I did. So by virtue of the way that it's designed, which is a factor of 25 simplicity over Scala collections, it's easy to specialize. Yeah. So it's not checked in, but one thing I did at one point was I could pervasively specialize literally everything on int, long, and double. Yeah. And yep, through the roof. In Scala, none of the collections are specialized. For me, list is, two classes with one method. I can specialize that. It's no problem. And I did. So, and then all of a sudden, hey, everything's super fast. And you can use extension methods and whatnot. I mean, there's a bunch of just better tools available than inheritance for managing this sort of thing. So, yeah, you want fast, definitely. You want fast, first make it simple. So that's the step I'm on, make it simple. But fast is way more available here than it's ever going to be in the collections, which cannot be fast, ever. Because inheritance is, the kind of crazy inherent parentage that they have in the collections is it's optimization poison on hotspot.
I don't know much about Scala, and I find it refreshingly honest to hear about the complexity part. I don't know that much about the detail. But here's the thing. There's some companies who claim they're very successful. Twitter's one of them, using Scala. Had they just been lucky? Are they going to eventually, is it going to be like a bomb exploding with them? Their system will implode? That bomb exploded at Twitter 2 years ago, I think. Take a look at the things that Twitter's had to do, for one thing. Twitter has implemented, re-implemented a bunch of stuff. They maintain their own fork of the compiler. They are stuck on Scala 2.9 and can't get off it because of this huge drag on the dependency spin out is so great that it's, God knows, maybe they'll never get off it. Who knows? You will not find an insider at Twitter who feels unreservedly good about the impact of Scala there. They've gotten a lot out of it. There's been a lot of good. There's been a lot of pain. Interesting. Thank you. I used to, when I lived in San Francisco, I lived just down the street from Twitter. So just to have somewhere to sit, I went in there for 6 months and just sat there every day. So I was just like a ghost drifting in and out. And so I have some firsthand knowledge of Twitter and the kinds of things that they encountered just in the course of, water cooler conversation. And it's just the kind of things I would expect them to encounter, which is to say, needless complexity.
So the intentional version of a set seems like it is just a predicate set. I don't know if that's interesting.
The intentional, yes.
Yeah, the intentional version. I mean,
right.
There's nothing else there except
that's
for
right. It's just a predicate.
A predicate. So
that's right.
I don't know if any of the other collections devolve that way to just a function.
No, but map is like half that, right? I mean, so map is half that. And remember, another of the tragedies of the collections is that set actually extends function one. This has all kinds of bad consequences. Not to mention map extends partial function. So these conflation of concerns that are totally unnecessary. There should be, if you really want these things to be, if you want the same thing to act like each of these things, then mediate it. Take the thing and act like the other thing. But by extending function one, they take everything out of your hands. You're forced, all my sets are function one. Function one is so heavily privileged inside the compiler in terms of type inference and all kinds of other things. It's terrible that it has infiltrated the collections in this way. The consequences are endless. They're all bad. It's interesting to see how SAMs will play out. Under -X experimental now, it'll do the SAM thing, which is if the expected type is a class or a trait that has a single abstract method, and you throw a thing that looks like a function at it, then it'll synthesize the class and call the single abstract method. So That's great, but it's already like super complicated. Like these things sound great, but the complications in the compiler are just completely nuts. Because you have to make all these decisions for which there's no right answer. There's no way to know. Like, what do we do when this thing happens? Corner case XYZQV. Well, given that it's totally unspecified, we're adding a new unspecified thing. Well, let's just do a thing. And then that's the thing. If you guys want to see this talk again tomorrow night, slightly more polished, that will be available in San Francisco somewhere, wherever they're sending me. Only slightly, whatever I can get done in 4 hours or so tomorrow. Yes?
Is there a subset of Scala that you would consider sane?
Sure, but there's no subset of the implementation that's sane. There's not. It's like if I could extract that, and I tried. So there was, before I quit, TypeSafe, one of the well, I won't quit, I'll just try to do something useful instead. One of my side adventures was a thing called Prime, where I attempted to strip out everything unnecessary from Scala, reduce it down. You guys don't know, you can't even imagine how hard it is. And it's like the worst kind of hard. It's like being, sent over to some like junky paradise where it's like you have to climb over needles and stuff, and it's all the work you're doing. There's nothing interesting about it. It's only my sick perseverance that I have. It is truly a sickness that allowed me to get as far as I did. But I realized it's crazy. I can do this from scratch. I can design it. I don't have to be like trying to get somewhere good by fighting my way through nails and broken glass. I can just. This is software, it's magic. We can just synthesize it from our thoughts. So I said, screw this, and came back and took one more shot at working on the regular Scala, and then I gave up.
I have to ask you, because you're a lot smarter than I am, what do you think in 3 years things will be? Go, Node, Scala, where will they be or not? Just your thoughts.
Well, I expect, all this aside, I expect Scala and TypeSafe to do well for many of the same reasons that like other sort of monolithic languages do well. People come to depend on them, and there is a sort of like emotional security in all of the sort of like painful independencies and intertwingling, and these things have a life of their own. I genuinely expect Scala to do all right. Node, God knows, right? People are attracted to the weirdest things. This is truly a fashion-driven industry. It is. You're asking me to predict like what next year's fashions are going to be. I don't know. Hem lines will go up a little. Wherever we are in the cycle of hemlines, I truly think it's like tea leaves. It certainly doesn't have anything to do with what's good or useful. So I don't know. I just don't know. I only know that the best way to predict the future is to invent it. So, well, Go. He asked if Go could be a bootstrap language. So if I really held my breath, and again, because of that one thing, I hate almost everything about Go, like in terms of like their choices in the language, but because of that one thing, that means something to say that there are two implementations. It means that they're like, regardless of anything else, that there's an ethic behind it, that they actually want something beyond an implementation-defined language. So that's almost enough all by itself. But I think it's not enough all by itself, and then I don't think there's anything else to get me. Like the idea that generics are, that's nuts. They truly appear to have ignored at least 80% of like the last 40 years of research. And I can't understand that. It's like, it's one thing to say like, yeah, we're not doing this and that. But generics? Come on, man. You're just living in the 70s, truly. There's no way you can. I want Scala's type system to some extent, but just that works. The truly frustrating thing is how it just doesn't work. And if you there's so much that could be done with type computation if we didn't make it so ridiculously hard, and if it wasn't so laden in bugs everywhere you look. I'm sure anybody who's like worked on something like Shapeless or Scala Z knows exactly what I'm talking about. Well, the stuff that those languages do, it's these amazing achievements, and it's like building a starship out of Legos. It's like, look at the starship I built out of Legos. I'm like, yeah, that is awesome. Why are we building starships out of Legos?
Hi, thank you very much for these very insightful details. Many things were quite new. And also thank you for our good neck exercise following you on the stage.
Okay, I'm sorry,
The neck exercise that we got following you on the stage.
what's following me?
The neck exercise.
Oh, yeah. There's a good thing that I'm not like tied to the mic because I would just pull this thing down. I'm just a moving around sort of guy, except, well, that's because I sit at the keyboard all day, you know, in this sort of frozen rigor. Okay.
Anyway, my question was somewhere we got an impression that things are not changing in Scala because they are tied to the implementation in the compiler or the code. But there have been enough backward compatibility issues as we move from 2.7, 2.8, 2.9. So is it like some things are only selectively changed, which are like easy things to fix, or like some things are not really changed?
No, that may as well have been the 1800s for all the relevance that it has. Yes, 2.7 to 2.8, like massive breakage. That was a different world. With TypeSafe and with the assurances that have been given now regarding how backward compatibility is going to work and how it works, and the tooling that didn't exist at all in those days, even if anybody had cared, that now does exist. And you know, there's just the richer like the tests get, the more. The upshot is it's none of that matters. Now you're stuck, and it's good and bad, right? But the sad thing is, it will successfully accomplish binary compatibility, which is largely worthless. It's just a thing that you can say like, look, there's no linkage errors. It doesn't really tell you that much. It definitely doesn't tell you it's going to keep doing the same thing that it used to. And source compatibility is literally impossible to deliver because of the tiniest things that impact type inference will change the way your code base compiles or doesn't compile in a way that we could never anticipate, you could never anticipate, and we won't know till you find it. And that's just how it's always going to be, again, because there's no specification.
So speaking of the specification, you made some forthright comments about, you said it's out of date and not good things. Did anyone ever try to write a set of conformance tests based on Martin's spec? And if so,
nobody that I'm aware of actually can understand the spec. The closest is Mark Hara, who seems to actually have achieved a certain level of comfort with the language in the spec. But the spec is, people like to say it's readable. I would be fascinated to see the conformance test that somebody would put together. Because I think mostly people just speak from a position of no knowledge on these matters. I have spent an enormous amount of time with the spec, and it's garbage. It is impossible. It is so out of date with the implementation. It is actively harmful. And its existence and the way it's used as a club makes me physically ill. It is definitely by far the greatest reason that I quit, because I want a specification very much. I want an implementation that is done in concert with a specification. It's a two-way deal. This specifies that implements that. We're buddies, we go together. It may as well be like, you know, Holy Writ on the mountain carved in stone, and that's as often as it's updated, it may as well be. And you know, 500,000 lines of code later, there's this other thing over here. Meanwhile, people come and they say, well, the spec says blah. Who cares what the spec says? It doesn't have any bearing on anything. So no, nobody's ever tried anything like that, and nobody's saying would. I mean, try anything you can think of regarding the spec. I wish you luck, because it's pointless. It's a pointless endeavor. I can predict easily what's going to eventually happen. It will be burned, and Martin will have like cooked up a whole new thing. There's no way they're getting out of that spec. It's already dead. Body's lying there. People keep coming by, you know, like kind of jostling the body, not realizing that it's just dead, dead, dead. And then, you know, years from now, Martin's just going to go, all right, forget all that stuff. Here's the next thing. That's what you have to look forward to.
Thank you.
I love his choice of forthright, his choice of words. Yes, Yes, I attempted to be forthright on this matter, yes.
I'm curious, given your drivers on it, as far as I know, for instance, Haskell has 3 or 4 independent implementations, though there's obviously a driving one or two. It would seem to be an obvious match to your biggest pain points, given the cleanliness of the model and the like. So there must be problems here. What are they for you?
Well, yeah, Haskell, like, you know, people hear the way I talk, and they're like, yeah, man, it's Haskell for you. Well, let me tell you. So I invested a little bit of my heart in that, not very much, because I know better. And I've spent, like, I don't even know how much of the last month just trying to get shit just running in Haskell. So I got the very bad luck of being on Mavericks, which broke everything in the world, and having this confluence of like GHC bugs intersecting on me on top of like libraries that hadn't been updated for the trunk version of GHC, which I had to build. But the overall experience has been terrible, which puts it on an even par with, you know, other languages. And so, like, whatever sort of like false optimism I might have allowed myself to feel that things would be different in Haskell is gone, because Cabal is like really like bad, honestly. And I was like super unimpressed with that. And then like there's just a bunch of libraries that just don't work. The dependency nightmare is just as bad as it is anywhere else. And these are like not primarily about the language, but it's not the language that I care about. In fact, I wish people would stop talking about languages. I'm interested in tools for creating software. That's a bunch of stuff. Language is just a thing. It's not even the most important thing. And so as far as I can tell, Haskell is not doing any better here than anybody else, unfortunately. But clearly, like, the language itself is, you know, does some of the things I'm talking about a lot righter than most. I just don't think I've had a brief month or two flirtation with Haskell right before Scala, in fact. And I just feel like it's not quite right. It's just laziness is the default. This is a weakly held opinion, but it's just my feeling. And I feel like it's not as accessible to people, regular people, as it should be. I really want to find the thing that lets the regular programmer, sane, sensible, reasonably smart guy, get advantage of the huge amounts of ways we have of making more correct software without it seeming like they have to climb this crazy mountain. I honestly think it should be easier to do the right thing than the wrong thing, and that it's possible to make that environment where it's easier to do the right thing than the wrong thing. And if Haskell does that, it does that like there's an inaccessibility sort of to it, like whether that's just like a cultural vibe or just my crazy impression or what, but it's not as easy as it should be. I want it to feel like JavaScript, which is like, yeah, I'm going to go do that, but not act like JavaScript. I don't know. He asked if I could get on top of Haskell, could I use it as a bootstrap? I don't know. I see a lot of guys doing that, right? Like, I mean, all these languages, Idris, on and on, presumably they're all implementing it in Haskell, right? And this is like the thing everybody does. Well, if there's one thing that I feel like if I just lock onto Haskell and do the thing, all the other big, like I'm gonna be the smallest brain in the Haskell pond. I mean, if I have any kind of chance of doing anything interesting, I think it's like I need to distance myself from Haskell, because it's almost like there's too many sort of like brains doing similar sorts of things, and either they're going to accomplish it without me or they're not. But I don't feel like I'm going to change that equation materially. Whereas if I go at it in a completely different direction, maybe I reach a bunch of people that I wouldn't have reached that way. I mean, I don't know if that's like just some irrational justification or what, right? But anyway, that's also a weakly held opinion, maybe.
Thank you, Paul.
You're welcome.